Let's take a look at lesson 7.1, ratios and proportions. So what is a ratio? A ratio is a comparison of two quantities by division. So it's a fraction. Ratios can be written in three ways. So you can write as a fraction, as long as b is not 0. You can write it using a colon, so a colon b, and using words a to b. Typically this will be in a word problem or in a sentence type form. One thing to note is they're all three said the same. A to B, and A to B. Whatever comes before the word to is usually your numerator. Comes after is your denominator. So pay close attention to how the wording of these ratios are. I'll let you know what is your numerator, what is your denominator. Now one thing you want to make a note of is that typically we're going to express these ratios as a fraction. And we're going to do it in the same units and in simplest form, which means we're only going to compare apples to apples, not apples to oranges. So if you have two numbers in different units, in order to simplify them, you first have to get them into the same unit. So let's take a look at our first example. The bonsai bald cypress tree is a small version of a full-size tree. A Florida bald cypress tree is called the senator, stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the senator? So let's take a look here at the question. It asks for the height of the bonsai to the height of the senator. So here's the word to, which kind of represents our fraction bar, which means anything that comes before it is going to be our numerator. Anything behind it is going to be the denominator. So we're going to look at both of the heights. So we're going to look at the height of the bonsai over the height of the senator. Now, let's take a look at what they gave us. The bonsai height is 15 inches. The senator tree is 118 feet. Now, we can't simplify this yet because one is in inches, one is in feet. So let's take a look at this, and it's easier to always take our larger unit to smaller unit. So we're gonna simplify. We're gonna put this into inches. So we start with 118 feet. Put it over 1, and then we're going to multiply it by its unit conversion. Well, we know there are 12 inches in a foot. And because we want our answer in inches, we're going to put inches on top and feet on bottom. This way, our feet will cancel, leaving us with only inches. Now, there are 12 inches in 1 foot. So if you get confused on whether you're going to multiply by 12 or divide by 12, this is one way to make sure that you're doing it correctly. The feet and feet cancel, leaving us with just inches. So as we multiply this together, we're going to get 1,416 inches. So let's bring this back up here. We have 15 inches, and now we have 1,416 inches, which is equivalent to 118 feet. So now we look to see, can we simplify? And you can use your rules of divisibility to recognize that 3 goes into both numbers. It goes into 15 5 times, and 3 goes into 1,416 472 times. And so this number, because it doesn't end in a 5 or a 0, can no longer be simplified. And our answer is 5 to 472. Now one way, as I did this before, as I mentioned, if these digits, the sum of these digits can be divided by 3 evenly, then 3 goes into this number evenly. So that's why we chose 3, because 1 plus 4 is 5, 5 plus 1 is 6, 6 plus 6 is 12, 3 goes into 12 evenly, so 3 goes into this number evenly. So we get our ratio is 5 to 472, which means for every 5 inches of the bonsai tree, it is equal to 472 inches of the senator tree. All right, so let's take a look at another one. You try this one. The bonsai tree is 18 inches wide, stands 2 feet tall. What is the ratio of the width of the bonsai to its height? So pause the video now, work this one out, and come back and check your answer when you're done. All right, so once again, we look here, it says the width of the bonsai to the height, which means the width goes on top and the height goes on bottom. So we take our two numbers, 18 inches to 2 feet. We convert this into inches, which is multiplying by 12, and that gets us 18 inches over 24 inches. Reduce down by 6, and we get 3/4. All right, so now let's take a look at extended ratios. An extended ratio compares 3 or more numbers. In this extended ratio, the A to B to C, the ratio of the first two numbers is A to B. The ratio of the last two numbers is B to C. And the ratio of the first and the last numbers is A to C. Now, so what this means is we're going to use this and help to solve some of our problems that involve totals or sums, products, quotients. So let's look here. The members of a school band are buying pots of tulips and daffodils to sell at their fundraiser. They plan to buy 120 pots of flowers. The ratio of tulip pots to daffodils will be 2 to 3. How many pots of each type of flower should they buy? Well, in order to set this problem up, we first need to look at the 2 to 3. What number represents the 2? What number represents the 3? So we look here at our statement right here. The ratio of tulip pots to daffodils will be 2 to 3. So they tell us our ratio. Tulip pots to daffodils, which means our tulip pots, tulips, is going to be the 2, and our daffodils will be the 3. Now, the next part, it takes a little bit of explanation here to kind of understand. So what we're going to do is we're going to take the 2, and we're trying to figure out what number can we multiply by 2 and 3 that when we add it up, it becomes 120. So we're trying to figure, we'll put our unknown as an x. So 2x plus 3x is equal to 120. So to kind of explain this a little bit better, let's take a look at this a little bit further. If I took the fraction 2 to 3, and I look over here, and let's say this number is 8 over 12. Well, what did I multiply by? What number did I multiply by to get the 8 over 12? So 2 goes into 8 4 times, so we're multiplying by 4, which means we're multiplying 3 by 4 to get 12. We're multiplying by the same number. We haven't changed the value of this because what we're doing is we're multiplying by 4 over 4, which is 1. Anything times 1 is itself. So 2 over 3 can become 8 over 12. So let's kind of apply this to this. This total of this problem would be, if I took 8 plus 12, that would give me a total of 20. So I add it together to get 20. So if the question was, what do I multiply by 2 and 3, that when I add them up, I get 20, it would be 4. So now this problem says, what can I multiply 2 and 3 by that when I total them, so this will be the tulips, this will be the daffodils, when I total them up, it's going to give me 120. So the way we do this is we set up this extended ratio. So 2x and 3x gives me a total of 5x. So 5x is equal to 120. Divide by 5, and x is equal to 24. That means if I plug this in here for 24, okay, we'll plug, this in for 24, and 24, that's my magic number. Now 2 times 24 is going to give us 48. 3 times 24 is going to give us 72. If you add these two up, 48 and 72 is going to get 120. So to answer our question, how many pots of each type of flower should they buy? Well, we just answered it over here. Tulips, you're going to be 2 times the 48 to get, 2 times the 24 to get 48. So 48 tulips. And for daffodils, we're going to take the 3 times the 24. That'll give us 72. So you can use extended ratios in a number of different problems. A lot of times when they deal with totals. It may be a problem where you have 2 different types of angles or 3 angles. So let's take a look at the next one. The measures of 2 supplementary angles are in a ratio of 1 to 4. What are the measures of each angle? So use a extended ratio to help set up and solve this problem. Pause the video, come back and check your answer when you're done. All right, first, as we read this, we have to know what the definition of supplementary. This could read complementary, this could read a number of things. So supplementary means 2 angles that add up to 180. So we have angle 1 plus angle 2 equals 180. Now these angles are in a ratio of 1 to 4, which means we have 1x and 4x added together to equal 180. Combine our x's, we get 5x equals to 180, divide by 5 and get x equals 36. So that tells us that angle 1, since 1 times 36 is 36, it's going to be 36 degrees, and angle 2 is 4 times 36, which is going to give us 144 degrees. Now you can always double check this by making sure that 36 plus 144 is in fact equal to 180, and it is. So let's try one with giving us another total, a perimeter. The lengths of the sides of the triangles are in the extended ratio of 3 to 5 to 6. Since we have three sides of a triangle, that's why we have 3 ratios. The perimeter of the triangle is 98 inches. What is the length of the longest side? Now, since 6 is our biggest ratio, that means this number is going to help us find our longest side. But before we can do that, we have to find out what is that number that we're going to multiply by each one of these, that when we add them up, it's going to be 98. So we'll set up the same type of problem. 3x plus 5x plus 6x equals 98. Because remember, our perimeter is found by taking 3 sides, side 1 plus side 2 plus side 3 equal a total, equal our perimeter. So we're doing the same thing here. So we add our x's together. That gives us 14x equal to 98. Divide by 14. And x is equal to, let's see, that's going to be 7. So now we'll go back and find our side lengths here. So we have the side 1, which is going to be 3 times 7. That'll give us 21. This will be in inches. Side 2 will be 5 times 7, which will be 35 inches. And then side 3, the one we were looking for our answer, is going to be 6 times 7, and that will be 42 inches. This is our largest, so what is the length of the longest side? It is going to be 42 inches. All right, so let's take a look at this one. The lengths of the sides of a triangle in the extended ratio of 4 to 7 to 9. The perimeter of the triangle is 60 centimeters. What are the lengths of the sides? So try this one, pause the video, come back and check your answer when you're done. All right, so this has the same setup. Add 3 sides up to get our perimeter. 4x plus 7x plus 9x equals 60 to get an answer of x equals 3. We plug that answer back in, we get 4 times 3 is 12, 7 times 3 is 21, and 9 times 3 is 27. So now let's take a look at another one. The lengths of the sides of the playground are in the extended ratio of 4 to 3. The area of the playground is 588 square feet. What are the dimensions of the playground? All right, this problem is just a little bit different because this one, notice, is talking about the area of a playground. Whether we did perimeter where we added up and set it equal to that perimeter or that total, this one is just a little bit different. So we got to think of how do we get the area of a rectangle. Since Since we only have two dimensions, it has to be either a rectangle or parallelogram. Both have the same formula. So we have base times height. Now, so we've got the 4, since it came first, we'll let this 4 be our base, and this will be our height. So if you think of this rectangle here, we have a base, and we have a height. The area of this problem is going to be 588 square feet. So when we set up this equation, we're going to work it the same way, but we're going to do it just like an extended ratio. So we're going to have 4x times 3x is equal to 588. So what we're trying to do is we're trying to figure out what can I multiply by 4 and 3 that would I take their product and get 588. So we multiply these two together. And a lot of you will make a mistake and you'll just put 12x, but it's x times x, which is x squared equals 588. So we start by trying to solve for x, so we divide by 12. And then we're left with x squared is equal to 49. So what we've got to figure out is what can we multiply by itself to get 49? And the way you find that is by taking the square root of both sides. Square root of x squared is x. The square root of 49 is 7. That means our value of x is going to be 7 for this problem. So that means our base is going to be 4 times 7, which gives us 28. And our height is going to be 3 times 7, which is going to be 21. Now, one way to check this is to take 28 times 21 and see if, in fact, it does equal 588. All right, now let's look at cross products. An equation that states that two ratios are equal is called a proportion. So two ratios meaning two fractions are equal. And when they're set equal to each other, we call those a proportion, which means that we're going to be using cross products or cross multiplying. So 2 over 3 is equal to 4 over 6. They're both the same thing. This is the reduced form of this fraction. And to cross multiply, to make sure we're on the same page, I know you guys have done this before, 3 times 4 and 2 times 6. So the product of 3 times 4 should be equal to 2 times 6. So they both get 12. Therefore, we know we've done it correctly. So now let's take a look at how we're going to use these cross products to find missing value. So let's take a look at these. We have 4 examples here. We're going to look at the first 2 together, and you're going to do the second 2 on your own. 6 over x is equal to 5 over 4. So these two ratios are equal, so we're trying to figure out what we can put in for x that's going to give us the same ratio as 5 over 4. Now, one thing to remember is not every one of our answers will be a whole number. So as we multiply through here, we get 5x, and then we get 6 times 4. So 5x is equal to 24. And even though 5 does not go into 24 evenly, don't panic, your answer will just be 24 over 5. It is okay to leave an answer in fraction form. Now let's look at the next one. Y plus 4 over 9 equals y over 3. So once again, we have two variables here, but we're going to cross multiply. So we're going to multiply 9 times 4 and 3 times y plus 4. So what we have to do is this is 3 times the entire expression y plus 4. So 9y is equal to 3y plus 4. Now in order to solve this, we need to get rid of the parentheses. The way we can do this is by distributing it through here. So 3 times y is 3y. 3 times 4 is 12. And now we set it to bring down the 9y. So we subtract 3y. And that gives us 6y is equal to 12. Divide by 6, and that leaves us with y is equal to 2. So if we put 2 plus 4, that gives us 6. 6 over 9 reduces to 2 over 3. So I want you guys to try parts C and part D. Pause the video, come back and check your answer when you're done. So in this problem, we do 2 times A equal to 9 times 14, which gives us 126. We divide it by 2 and get A is equal to 63. Now sometimes you can make this relationship between the 2 and the 14, the two denominators, or maybe even with the fraction itself. So 2 multiplied by what to get 14? That's going to be 7. So if you multiply by 7, this gives us 14. So we've multiplied the top by 7, we're going to get 63. So that's another quick way to do this instead of using cross multiplying. You could have also done 9 divided by 2. That's 4.5. Well, 14 times 4.5 is going to give us 63. All right, so this one here, a lot of people make a mistake on this one only because the last step. Multiply, cross multiply here. So we start with 15 times m and then 3 times the parentheses m plus 1. So when we distribute, we get 3m plus 3. And don't forget to multiply the 3 by the 1 as well to get 3. Now, we're going to subtract the 3m over to get 12m. Bring down the 3, and now we divide by 12. We want to get rid of the 12 by the m, so we're solving for m. And we get 3 over 12. Now, a lot of people put 4 as your answer because we know 12 divided by 3 is 4. But the way this is set up, this is a proper fraction, and this just fraction needs to be reduced. So it reduces, 3 goes into 3 once, it goes into 12 4 times, so we're left with 1 over 4. So be careful on how you answer your questions. It's okay to get a fraction. All right, so let's take a look at this example here, writing equivalent proportions. X over 6 is equal to y over 7. So what ratio completes the equivalent proportion of x over y? So if you look here, x over 6 equals y over 7. Well, if we rewrite this as x over y equals blank over blank. So what has happened here? Well, the x is in the same position, but where the 6 was down here, we've got to figure out where it's going to go next. And the y has come down here. So in order for our cross products to be still multiplying the same thing, that means that the x and the y have to switch places. So this becomes 6, and therefore this would stay in the place of 7. Because in order, you can change these around, but you're still going to have to multiply the same numbers. So when you multiply 6 times y and x times 7. So I can rearrange it as long as I'm still multiplying the same numbers together. Which means there's a relation between the numerators and there's a relation with this x with its denominator. It's also with this other numerator. Just like there's a relationship between the 6 and the 7 and the 6 and the x. So as we saw in our last problem, where we had our two equivalent fractions where we had the 9 over 2 and the a over 14. There was a relation between the numbers going this way, 2 into 14, and going this way here. So 9 is to 63 as 2 is to 14. 63 divided by 14 is 4.5. 9 divided by 2 is 4.5. If you swap these two places, okay, if we swap these two places, so if we did 9 over 63, and then the 2 and the 14 stayed the same, this reduces to 1/7, this reduces to 1 over 7. So just showing you there's several different ways to set up proportions and still get the same answer. So let's take a look at our last example. You draw a face. You can sketch a head as an oval and then lightly draw horizontal lines to help locate eyes, nose, and mouth. You can use extended ratios shown in the diagrams to help you place the lines for an adult's face or for a baby face. So let's take a look at the first part. If AE, which is the adult face, is 72 centimeters in the diagram, find the measure of AB, BC, CD, and DE given the following ratios. AB is 4, BC is 2, CD is 1, and DE is 1. So pause the video and use an extended ratio to help find the measure of each segment. All right, so we know that the segments AB plus BC plus CD plus DE is equal to AE, segment addition postulate. All these segments equal the total segment AE. So we take and use an extended ratio, so we do 4x plus 2x plus x equals 72. Add up our x's to get 8x, divide by 8, and we get 9. So when we plug this back in, this means that this 4 times 9 gives us 36, so this is going to be 36 centimeters. So 36 centimeters from A to B. This is going to be 18 centimeters. And this is going to each be 9 centimeters. Since these are both the 1 and 1. So if you add all these up, you're going to get a total of 72. This way that everything is proportionate and everything looks right. You don't want the person's eyes to be way down here. Okay, so you have to follow the right proportions. All right, so this concludes our lesson on ratios and proportions.